and machine learning using Microsoft.NET. So before I start the session, I'd like to thank Paras, Vivek, and the Microsoft for organizing such kind of events, which is very encouraging for the audience plus for the speakers in terms of enhancing the knowledge. That is plus how we are going to utilize the things that is happening in the Microsoft world. So uh, based on that, I like let me share my screen. So I hope you are able to see my screen. Just type in yes or no before I start.
Yes, Praveen.
Okay, thank you. Uh, so what we are going to do today is we will look into the data science and machine learning using Microsoft.NET. So predominantly these two fields are being captured by different languages or frameworks such as Python and R. And for .NET developers, there was nothing as such wherein they can try their hands and try to create some applications using for using machine learning and data science. But in the past 1 or 2 years, Microsoft has invested a lot just to have something for the .NET developers so that they can also try their hands and learn and apply these concepts to produce some remarkable applications that can be utilized in the enterprises. So a short introduction about me. I'm a cloud architect at Harman. It's now a Samsung company, and the domain I've been working is audio, video, and control. The area of expertise is cloud and distributed computing, and the interesting area for me is AI, ML, cloud, and IoT. And I'm based out at Bangalore, and I'm part of the .NET Foundation as well. I've been contributing a little bit in that space. Plus, I've been a community speaker for the past 1 year, uh, wherein I share my knowledge with the community, and I've been participating in various community events as well. For example, the ones that have been organized by Microsoft Reactor here in Bangalore, and plus the .NET meetup. So wherein I used to get a lot of knowledge and got to know what other things are present in the .NET ecosystem or Microsoft world. So, so just a little bit of acknowledgement. So dataset for today's session has been provided by John Hopkins University. Then there was a Python notebook or visualization by Akshay SP. This is the link provided here, and he has written it very well. I tried to get some information from there and use it in my application. Then the organizers like Vivek and Paras, and the sponsor is like Microsoft. So before I start, just wanted to have a quick check on how many of you have worked on .NET or tried their hands in .NET, or this is the first time. Maybe you can put yes, no in the chat. Okay, great. So looks like we have a good audience who knows about .NET, but there are few members as well who are new to this field. So I will try to capture the basics, plus I try to have capture going from the basics to little bit intermediate then to the advanced. So just bear with me if you are not from the .NET background. I'll try to make it as simple as possible for you guys. So why do we need a .NET thing? So what language is this? Maybe you can type in the chat. Great. So it's a French word. Then this one, it, and this may be a little hard for some people. So this is Japanese and it's termed as konnichiwa, and all these means good morning. So you have different ways of communicating between different people. So the same verb that we are using here, like good morning, and it has been described in different languages, so it becomes little hard for us to interpret, even though we know what it is. So like we know good morning, but we can't interpret by looking at the thing that is present. For example, if you have to interpret from the Japanese words, it's difficult for someone to new to this language. You may get easily get a conflict between like Korean, Thai, or Japanese or Chinese, but until and unless you know the internals of that language, you know the basic characters within that language, it becomes really a challenging part for you. The same is the case for our programming languages. So we have plethora of programming languages present. For example, you have C Sharp, JavaScript, Java, C++, PHP. So for a developer has been working on one language predominantly, it becomes a challenge for him to learn a new language or apply a new concept or a new advancement in the technology because of the limitation that he has with respect to the language. So if you are working in a .NET world and you see that there is a lot of advancement happening in Python and R or some other language, so your whole time goes into understanding the basic structure of those languages. Rather than focusing on the business part of it, you mainly focus on understanding the syntax, understanding the concepts within that language, understanding how you can apply the different things present in that language. So it becomes a challenge for everyone. So that is the problem that .NET developers have been facing for some years, as there was not much advancement in terms of the uh, language. There have been some thing present in terms of the Azure, in terms of the machine learning and AI, artificial intelligence, but that was predominantly from the Azure perspective. So from an Azure perspective, there also the support for the language, especially the C sharp, the F sharp was not available. There also you need to write the code in Python and upload your notebooks and run your machine learning algorithm and other things. So now for the past 1 or 2 years, the Microsoft has invested a lot in that one, considering the .NET ecosystem, and they have come up with some of the frameworks that is can be used by .NET developers. So basically, I'll be covering two things today in terms of the data science and machine learning. From the data science part, I'll be covering the exploratory data analysis, and from the machine learning part, I'll be covering the predictions or the time series predictions, where we can evaluate, okay, how good is our model and how we can predict for the future occurrences. So just a recap on the exploratory data analysis. So this is a wiki definition. So in statistics, exploratory data analysis is an approach to analyzing data sets to summarize their main characteristics, often with visual methods. So what does it mean? It says that it's an approach of analyzing the data and representing visually so that you can make better decisions. So if I give you just a same CSV file or some data with in a tabular form, it's difficult for you to interpret what is happening in that data, what all those numbers represent, how they are related, how they are not related. So it's a challenge for a person who has a raw data in itself. So exploratory data analysis helps us in creating some visualizations that help us make better business decision that adds value to the business. Another thing is like a statistical model can be used or not, but primarily EDA is for seeing what the data can tell us beyond the formal modeling or hypothesis testing task. So EDA can help us in visualizing, and it can tell us what is present in the data, what is not present in, what is the missing data, what are the irrelevant data. So all those things can be done using EDA. So for example, if you consider a case of a house, and you wanted to analyze, you wanted to buy a house, so what all things you will consider for that one? For example, you will consider the features such as number of bedrooms, whether it is a apartment or a villa, locality, and the crime rate. So these all things are your criteria or the feature that will help you help in making a decision for buying a house. So if you are given with this kind of a data set, you will be able to make a better decisions out of that one. Now, in exploratory data analysis can be done using a data frame. So data frame, it comes from other languages also. For example, Python has been using it for a long time, and it is nothing but a tabular data which has rows and columns. And when you suppose this is from your CSV file, this is how it is represented. And when you load it into your programming environment, then it gets converted into this one. So we generally use this one for analysis, exploratory data analysis, the data frame. So for machine learning, I'll be covering touching base on the predictions or the time series analysis, which allows you to forecast some values based on the past predictions, past events that has occurred. So it's like it's the analysis of data organized across units of time. So here you get a data and based on the time. Okay. So you consider only one feature. For example, you wanted to buy a house, so you may consider what is the area of the house. So area of the house and the time. So based on that, you can predict what will be the price of the house. So these are the two things. So similarly, you can get to know about what all things are happening. For example, in case of COVID-19, you can predict how will be your prediction for the next 7 days, next 30 days, or next 3 to 4 months. So it helps you understand past trends and plan for the future. So there are different type of time series analysis that are done. For example, it is being divided into trend, seasonality, irregularity, and cyclic trends. You see some trend happening. For example, Flipkart sale is coming, so big billion days kind of thing. So those can be like trend which happens once in a while. Another one is seasonality. For example, you have different seasons, winter, then summer. So in those seasons, the sales may go up or sales may go down. For example, if is the case of a air conditioner, then the sales will go up in the month of summers, whereas it will dip in the month of winters. So same way. So irregularity where you can't predict exactly what is because of the one environment or the other environment. For example, now we are facing a COVID-19 situation where the business never expected that such kind of situation will occur, and they may have to incur a loss, or their sales may go down because of these kind of situations, which may happen anytime, but not one due to some past occurrence, or due to it can happen due to some reason or the other one. Cyclic means it can happen at a certain interval of time. So same set of patterns can be visualized at a set of intervals, at a certain set of intervals. So before I jump into the ML.NET and the Microsoft.NET, I like to briefly touch upon basics of machine learning, and then we will go into that other part, the .NET word. So The way the machine learning works, like for this is a question, what is this? So it's, if you see it here, it's like it's a normal fish. Okay, then there is another this, how about this? So this is also a fish. Then about this is also a fish, but we have three different type of fish, but all are categorized under one thing called as fish. Now what machine learning does is it takes all this data and feeds it to the computer or the system or the machine, and it comes up with a prediction, okay, what it is. So we are feeding the data to the machine and it is giving us the result. So we are not writing any algorithm here. For example, we are not writing any rule based engine here. For like this is a fish or this is a cat, this is a dog. So that all thing has been done by the machine learning algorithm. We are just feeding the data and getting the output. So machine learning is getting computers to program themselves. If programming is like automation, then machine learning is automating the process of automation. So if you look at the left side, we feed in the data and we write a program. Okay, it can be like a rule-based engine wherein you feed in the data, you get write a program and you feed it to the computer and it gives you the output. Whereas in machine learning, you just feed in the data and you know the output, what the output is. For example, it's a fish or it's a cat, it's a dog, and you feed into the computer, and computer what it does, it predicts, develops an algorithm, and it tells you what is that algorithm. So program is nothing but your algorithm, which tells you, okay, if you feed such kind of data, it will be of this feed kind. If you feed a fish to it, it will be a fish. So those algorithm is being developed by the computer and we use that algorithm. So here the things are totally different and it's not a rule based, like not a if else kind of situation, because if you are trying to write something if else and those kind of things, it becomes tedious to have uh, all the cases covered within that thing, and it really becomes challenging for example, you are working on a algorithm to uh, detect a spam or not for an email. So you don't know what all rules are there. Tomorrow something else comes up, then you have to apply, add one more if else for that one. So those things become challenging, but in this case you know feed the data with assumption that you are knowing about the whether it's a spam or not, and you give it a new data, and based on the previous algorithm that you is being developed by the machine learning algorithm, then you feed a new data and it will predict whether it's a spam or not. So basically, there are some prerequisites of machine learning. It's not like every problem can be solved through machine learning, or it must be solved by machine learning. So you need to be very careful in that one. You should not over apply the concepts of machine learning to a simple problem. If it can be solved through a simple rule-based engine, better to go with that one. If you think it requires a scaling, then you should go for the machine learning. But for normal and simple tasks, we should avoid using a machine learning things. So these are the prerequisites. Like a pattern should exist, means if we are feeding images of fish, then it should be able to predict the fish. So if I feed in four type of fish today, and tomorrow fifth kind of fish also comes, then it should be able to predict that one. So there is a pattern of characteristics that is present in the input, that will be utilized by the machine learning algorithm. So a characteristic could be anything like eyes of a fish, then a tail of a fish, then feathers, then the body shape of the fish. So these are the different characteristic or unique characteristics of a fish that help a computer to understand, okay, this is a fish, this is not a dog because it doesn't have a four legs, so it's not a dog. So those are the characteristics that has to be evaluated for applying your machine learning engine. and you know that there is no mathematical model or algorithm that is present. For example, you have been writing an algorithm for uh, um, sorting. So in that case, you know the algorithm, how to sort, whether it is through bubble sort or insertion sort or different algorithms you know in advance. So you have already developed those kind of things. So better not to use machine learning in that case. But yeah, if you feel that it is something which requires a lot of input data plus it requires a lot of use cases, then better go with and machine learning and try to develop some algorithm of machine learning. And you need to have a lots of data with because data is the king here. If you don't have data, the algorithm will not be able to uh, come up with a better accuracy. So by accuracy, what I mean here is in the thing that you are feeding to the as an input and the output that you know the difference between that. So if I'm feeding a fish and I'm predicting it as a like a bird, then that is wrong. Both are right in the shape. They may look very similar, but both are different. So we need to have a lot of data. If my data does contain enough amount of fish, then it will be able to predict. But if it contains lot of birds and not the fish, then it may not work very well. So you need to have a lot of data for applying the machine learning concepts. Then there are different type of machine learning. uh, so for example, you have supervised, unsupervised. So in supervised itself, what does it mean? That you feed in the input and you know the output in advance. So for example, I know I'm feeding a image of a fish, then I know that it's a fish. So I label that one. So the concept that is being used here is the labeling. So you have the label and you have the input both. Whereas in unsupervised, you don't know the labels, you don't know what it is. So you feed in the it to the system, and system itself predicts whether it's a fish or not. So it creates a cluster out of that one based on some characteristics, but there is a possibility that it may not be able to predict correct. Then you have classification and regression. So classification is generally like you wanted to check uh, whether it's a fish or not. So you are classifying the things. And whereas in regression, you wanted to predict whether what is the time is it revolves around the discrete manner. So you need to understand what all things will be present in that one. So there won't be any classification like what will be the temperature tomorrow. So you can't say it will be 100 or 10 or 20. These are not the only three things available. The temperature can vary from 0 to any number. Whereas in classification, you specify whether suppose it's a gender classification problem where you need to identify whether it's a male or a female. So you give two things there. So you have to provide the number of parameters that is required for the classification. Then third one is lies under the clustering, under the unsupervised, whereas we just feed in the data and allow the algorithm to extract the information or the features, and it based on those features, it creates a cluster out of it. For example, it can create a cluster of if I give you a lot of images of cat and dogs, so it may give you a cluster of or maybe different objects. For example, I give feed in the data of animals and vehicles. So based on the different cluster attributes or features, it can come up with a different cluster for each of them. And so here in this case, it will be one cluster for animals and one cluster for aeroplanes or vehicles. Then the next one is reinforcement. So these are done based on the algorithm that are being learned. So it works on the principle of uh, penalizing and other things. Penalizing the thing, penalizing the things. So for example, if you give something to uh, if you the best case is autonomous driving, so wherein a vehicle is going on and it comes and a signal comes in, so it detects whether there is a red light or a green light or a yellow light. If there's a red light and it predicts okay, this is a red light, then it predicted correct. In that case it will give some points to that one. Whereas if it is a red light and it considered it to be a green light, then it will penalize that one. So it will start working on these points, and wherein one place it will add to those points, wherein another way it will penalize to those points and lower the value. So that will help the algorithm to learn on its own and make the system more robust. So I don't know how many of you have attended yesterday's .NET conference. It was really a great session that happened throughout the night yesterday. And this is one of there are a couple of slides I have taken it from there. So one of them is regarding the .NET ecosystem. So we have around like more than 1.5 million .NET Core developers as of now, and you see that number it's the number one most loved framework, the .NET Core, and it's based on the research done by the Stack Overflow. Then the .NET itself is becoming a great contributor in terms of the open source projects. For example, you have everything nowadays, whatever the Microsoft is developing is mainly open source. You can go through that one and you can check the code there, and it's very easily available. Plus they have created a .NET Foundation which allows you to create different set of projects which are being uh, governed by different authorities, not only from .NET but from other players as well. Then it is one of the top 5 languages on GitHub, and this is a very interesting thing. Like it is quite 7 times faster than Node.js, the OSP.NET Core that has been recently released. It's a .NET Core 3.1, and 40% new to .NET are students. So it's very encouraging to see that it's making a mark in terms of the new people who are just graduating from the college, and they have been leveraging this one. So the .NET has bounced back and it has been doing a great job in the past 1 or 2 years. So it's like the 5 million .NET developers we have in Visual Studio family. Then .NET Core is 600K new members. Then 2 million publishes on .NET. So the best part now is .NET Core runs on any platform, whether it is Windows, Linux, or Mac. So you build at one place and you get it everywhere. So .NET Core has been very you can say a remarkable change that has brought into the Microsoft .NET ecosystem. Now coming to the machine learning framework, so there is a lot of frameworks available. For example, you have PyTorch, you have MXNet, you have Cognitive Toolkit from Microsoft Azure, then you have Keras, TensorFlow, Scikit-learn. All these what they are doing, they are helping the developers to write the machine learning applications with a less with a minimal effort that they can put up. So they expose a lot of libraries or framework that help you write application in a very simplified manner. but each one of them have their own pros and cons. And today I'll be talking mainly about ML.NET, that is from the .NET ecosystem. Okay, so before I jump into this ML.NET, any questions anyone has? Maybe you can mute yourself or you can type in the chat. Okay, cool. So I'll just go ahead. So ML.NET, it's a framework from Microsoft for developing custom AI and ML applications. It was originated in 2002 as part of Microsoft research project. So as we can see, it's around like 18 years old thing that is already prevalent in Microsoft ecosystem. And recently they just open sourced it for the community or the enterprises so that they can leverage the possibilities that is present in that one and develop a new set of applications. So this is like a paradigm of machine learning within different frameworks or libraries that are present. For example, if you wanted to have a easier or less control, so in that case, you will go with Azure Cognitive Services. Okay. And these are kind of like drag and drop, pre-built. You mainly focus on your business requirement. But the problem is this comes with a cost. So you need to pay the cost for the usage. You need to pay the cost for designing your machine learning application. For example, Azure subscription you need to have, and you can't have a local version of it. So these are the drawbacks of it. But someone needs a good prototype, or the customization is not there much, so then they should go with these kind of things. Whereas if you require a lot of customization, and if you want a more granular control for your application, for your uh, system, then you should go with ML.NET or Azure Machine Learning Studio. This is also something like that. But this also requires a Azure subscription, whereas ML.NET is mainly a framework which you can use. It's like a SDK which can use in your application, in a .NET application, whether it's a console app or a web API project or anything. You can just use it and create a machine learning application. So this is mainly for custom, and this is for like pre-built. And machine learning framework is made for .NET developers. So it's like build your own custom models by writing C# or F# code. It's mainly developer focused and not from the business point of view. For example, Azure Cognitive Services are mainly for the business. From the business point of view, they mainly you write, you have drag and drop and other kind of things, and that incurs a cost as well. Whereas this one is like it provides, it's on the developer focused, so it just provides the right amount of productivity and control. It's extensible, so tap into other machine learning toolkits with the rich extensibility model like TensorFlow. So the best part of this ML.NET is it has a binding with a standard called as Onyx, Onyx ONNX, which is a standard format of machine learning models. For example, you develop a machine learning model in PyTorch or Keras or TensorFlow. Now you wanted to leverage it into your .NET system, so you just export that one to your Onyx format, and once exported, you can just import it in your ML.NET in your .NET ecosystem. So as this field has been growing at a very rapid rate, so a lot of people have been investing their time, and they have been contributing in the community with their own solutions to some of the standard problems. So you need not to work on those problems again by writing a different your own custom machine learning model. You can just go and download the model from there. For example, if you are working on a PyTorch, if you are using a PyTorch, so there is a .pt file or .pth file that gets generated. You can convert that one into ONX format, that is ONNX, and you can import that ONX file directly into your .NET code and use it as it is. So there is no restriction for that one, and the opportunities to leverage a different solution that is already available, or the pre-baked solution that is already available, that can be utilized using this extensible mechanism. So this is one of the advantages of that one, and it has been proven. So it has been used internally in products like Office and Bing for many years. It's open source and cross platform, so you can run it in any of the platforms that you feel like. So I just talked about like proven at scale and enterprise ready. So it's been like in with Microsoft for the past 18 years. So that means they have been using it in Bing ads for making ad prediction, in Excel for chart recommendation, and PowerPoint for design ideas, in Windows 10 for in their Windows Defender for predicting the different type of hacks that are happening. Then in Azure Stream Analytics, so it is mainly used there for anomaly detection. So these are some possibilities that is present with respect to ML.NET. So you can perform a sentiment analysis, issue classification, image classification, object detection, forecasting, and predictive maintenance, then recommendations, customer segmentation, and there are a lot of things. This list is growing at a very fast rate. So not each and everything is present in ml.net, but to start you, these are the things that is present in ml.net, and Microsoft has been actively adding new things, maybe after at every quarter of the year. So this is a typical workflow of ML.NET or a normal machine learning framework that we have. So we prepare our data, that means we load the data, then we extract the features that is relevant to that problem statement. Then we build and train, in which we just train the model and evaluate how good is it, how bad is it. Then once we are convinced, okay, the model is quite well performing, then we just run the model and use it in our application. So application could be your .NET, it can be your .NET Core application, console application, or it can be a web API project or a web application. And this is your data pipeline for creating a ML.NET system. So you load a data. So data can be loaded in any of these forms. It can be of in the form of a text. It can be in the form of a binary. It can be in the form of a file, and you can provide a list of objects. So that means enumerable. And this is Packquet. This is mainly for high data, heavy data sets. Then you, once that load is done, then you need to transform the data set. So machine doesn't understand each and everything that is present in the data. It can be a image, it can be a data such as strings or something. Machine ultimately convert that into a uh, numbers. So it's binary like 1010. It ultimately converts everything into that one. So for those kind of a transformation, there are different transformations available. For example, converting a text, then schema changes, then finding the missing values. Then normalizing means if you have a image where the pixel values varies from 0 to 255, and you wanted to normalize it, so that in order to reduce the computation, so you divide that pixel value of a image by 255, just to give you an example, and so that the computations can be reduced in that case. Then encoding is there. Then feature selection means, for example, you have 10 features or 10 set of parameters which you got for a problem statement. In that case, you are only you only need to have three or four of them that are contributing to the that problem statement, and you feel that others are not relevant to that problem. In that case, you do a feature selection by looking at the data set that is available to you. Then once the transformation is done, you do the training means it's about you take the data, you feed into your machine learning pipeline, machine learning engine. It crunches those that data and it comes up with some kind of a algorithm. For example, I give a data to my machine to so it generally comes up with some kind of a equation. For example, for a straight line it may come up with a like y equal to mx plus c. For a quadratic equation it will be different. For a polynomial it will be different. So based on the problem statement that we are trying to solve, the machine learning engine will come up with that equation that will be as per the data that we have fed. So once the data is trained, in that case, after that we just evaluate means we just validate it based on the data that the model has never seen. So once it evaluates, and there are different factors or different ways of evaluating a model. And once you are convinced, okay, the model is performing very quite well for our problem statement and for our business value, we will use it to deploy to some place. So those places can be like Azure function, ASP.NET Core, console application. It can be a web-based application in terms of web API. So we will get that model and deploy it there, and after that we will start making a prediction. So once I have deployed it in my Azure function or a web API, I can feed in a image to it one and it will predict. So that prediction will be very fast. The training time will be time consuming because it need to learn the data set that is present and come up with the algorithm. So once it has already learned, the prediction part will be quite fast, as it just make use of that model that is present there and make a prediction out of that one. So to just for the example, I have used here the COVID-19 and data set, as I already showed in the previous slides where I did the acknowledgement. So I'll be performing a uh, analysis, exploratory data analysis and prediction use on COVID-19 data set. So before I jump into that one, here is a little brief about the COVID-19. So it's a coronavirus disease. It's an infectious disease caused by severe acute respiratory syndrome, coronavirus 2. We call it as SARS-CoV-2. The disease was first identified in 2019 in Wuhan district, the capital of China's Hubei province, and has since spread globally, resulting in the ongoing 2019-2020 corona pandemic. So this is something that has affected everyone across the globe. So this is a statistic. So if you look at these numbers, it's like 17 million confirmed cases we have as of now on July 30, whereas we have 0.6 million deaths. So this is a quite a large number, and it has been affecting our lives a lot. But there are some positive things are also happening, that the number of recovered cases are increasing. So that's a good positive sign, whereas the number of deceased cases are also increasing. So because of that, the government has been putting different kind of things or restrictions, for example the lockdowns and other things. But if you just look at these numbers, will you be able to make any judgment of this one? We can't make any judgment. Okay, okay, how this spread has gone in the past, whether it is number has increased recently or it has increased like 2 months back or 3 months back. So we can't predict all those situations just by looking at the numbers. So this is where the exploratory data analysis science. So you take these numbers and you start plotting this into a different kind of visualization. in order to make better judgment of this data based on the past occurrences that has happened. So now if you look at this plot, so this makes a sense, or it makes it looks more relevant to you now. Okay, for example, from January 31 till March 22, you can say the number of cases are very low, very low. But post that, the number have increased and it has gone like exponentially. So this tells us, okay, how the trend has been in the past, and based on this trend, the authorities, the government authority, the private authorities, or the people at home, they can take preventive actions against that one. Now we look at these numbers and we see the trend that it is already increasing and there is no decline in that one. So that means we need to be more careful in the coming time. So the exploratory data analysis really shines in this kind of analysis. And the way we do this analysis is using a .NET data frame in the .NET world. So I already talked a little bit about data frame, which is like nothing but a tabular structure that we put it inside an object and use it to uh, create different uh, objects out of that one, so that we can represent it in our visualization. So it is nothing but a collection of columns, and .NET data frame is a in-memory representation of structured data. So it's not like once you load a file, it will be available in the memory. You can't have it in a serialized way or in a stream based. It's very similar to Python data frame. So you can load a dataset from CSV. You can select rows or column. You can combine two data frames. So for example, you got a data frame for one time period, like for 1 year, then you got another time period data frame. You can just combine them together like you do a merging of two tables. You can perform different operations. For example, you can perform a group by, you can remove the null values. So these are the things that is present with respect to the .NET data frame. Now I'll be covering ML.NET prediction. So for that, I'll be performing a time series analysis on the COVID-19 dataset. So wherein there are different things. So there are different steps involved. I'll show you it in the notebook soon. So first one is like we will be loading the data set as I saw showed it in the previous slide, where we have the data pipeline, where you have you load the data, you transform the data, then you train the data, evaluate and deploy. So first we will be loading a data using a ML context that is present in ML.NET. Then we will creating a ML pipeline where we will be transforming the data and we will be training the data. Then we will be predicting the number of confirmed cases for the next 7 days. So this is the objective of this session. So and for this I'll be using a single spectrum analysis. So this is one of the ways of performing a time series analysis, very similar to what we have for moving average and ARIMA. So there are different ways of performing time series analysis based on the data set that is available or the problem statement that is available to you. But at present, ML.NET only supports single spectrum analysis. So I'll be using that one only for my demo. So there is something, this is little internal to the ML.NET and data frame. So in ML.NET we have something called as a IDataView, which is also a kind of a tabular representation of a data in an object. So if we already have our this thing IDataView, then why do we need a data frame? So I just made a simple comparison between these two. So for example, the data frame and data view are both part of different namespaces. One belongs to Microsoft.data, the other belongs to Microsoft.ml. Data frame is analogous to a list, which can be modified. It's always in memory representation. It You can add an item to it, you can remove an item from it. Whereas data view is like enumerable, through which you can just read the items. You cannot add any item to that list, or you cannot remove any item from that list. Data frames, it's a like .NET developer who are interested in data science, like exploration, it's mainly used by them. Whereas iDataView is mainly used for machine learning engineers who are involved in making a prediction or regression and image classification, those kind of things. Data frame is schema less, so that means you load a CSV file which is holding a list of columns, which is nothing but your different features, and you start playing around with that one. So I'll show you quickly on that one also. So you need not to define a schema for that. You need not to define a class which has to be mapped against your the CSV file or the columns present in your CSV file. So it's very flexible in that way, and it gives you a preview of all those things in a very elegant way. Whereas in iDataView, you need to define, okay, what are columns you are interested in from that CSV or from your data set, and you have to uh, get that one in advance before loading your data view. Data frame is eagerly loaded, means it's always in memory, and it's uh, whenever you load, it will be loaded in the memory at that point of time. iDataView is lazily loaded, means as soon as you access the members of this iDataView, then only it will be loaded. Otherwise it won't be. It will be based on the stream. So that is the next point. Like it's data frame is in memory representation, whereas iDataView is a stream based forward only cursor. Data frame, you can have a random access because it's like a in memory representation, so you can access it from any place. Whereas iDataView, as it's a stream based, so it has no random access, and it will be only forward only cursor access. There will be only forward only cursor access to it. Data frame is easy to debug. The reason being, it's already loaded in your memory, so you get full list of the items present there, and you can easily debug it. Whereas iDataView is hard to debug. It's mainly because it's a stream based. So currently the data frame supports only CSV, no other data type. Whereas iDataView is quite flexible, and a lot of things have been added in that one. And so for example, it supports CSV, enumerable, and now it also supports relational DB. And data frame follows a Apache arrow format, whereas iDataView, I already told, it's like a schema based. So I'll be performing some visualization with these things. So one is plot. So there is a library called as a plotly, which has a framework called Explot. It provides you different visualization, for example, bar plot, scatter plot, and pie plot. So I'll be using these things to display the data that is present in the CSV in different ways. So this is just a snapshot of the thing that I'm going to display today. So you have a data frame which allows you to see how the number of cases are there, like confirmed cases, then deaths, and then recovered, and then top 5 countries. So this is like a bar chart. Then for making the prediction, I'll be using this scatter chart, wherein we can see, okay, how the um, number of cases have been over a certain amount of time, and this is after like the prediction. So how the prediction is done after, if we provide this data to our model, how it will predict for the next 7 days. For example, if you see here, we can see it's very much in alignment with the previous pattern that has been there. So the previous pattern is about increasing the number of cases, so we could see that it has predicted quite well, wherein we can see that it is also showing that the trend is increasing in the number of confirmed cases. So the predictions is never is not 100% correct. So there will be always some variation in that one. So that is the reason we have some variation here in the prediction part. But it gives you a good idea, okay, how the prediction, how the trend will be. For example, it might, the trend would have come like a straight line like this, so then we can say, okay, it has predicted wrong. If there might be a trend that it might have come with a negative values, then we can say, okay, the trend is not proper. But at looking at the graph, we can say, okay, the trend has been going up. That means it is in accordance with the previous the past occurrences that have happened. And this is the value that I will be getting for the next 7 days. So let me jump onto the demo. Okay, so these are the references and these are the resources, and this is my you can contact me through any of these channels. So I'm running a Telegram group as well for ml.net. Maybe if you are interested, you can just join this one. I keep on posting new things in that one. So okay, and I have everything here, and like resources deck, then I have written our.
Why? We are not able to see your screen for quite some time.
Oh, just a minute, sorry about that. Are you able to see the screen now?
Yes,
Can you
but you
show the
mentioned no.
previous slide?
Yeah, Telegram and all. Could you paste those links in chat?
Yeah, sure, I'll do that. So can you help me where I left, where till where you were able to see the slides?
Go to the previous slide. Yeah, next one, next to demo. I think 36.
Okay, okay. So till here you were with me. That's good. No problem. I think nothing got missed. Uh, okay, let me put these two things maybe in the chat. So this has all the information, and this is some article that I wrote on dev.to, which covers the thing that I'm going that I have presented here. This is in a like so I'll brief you on that one maybe in the at the end of the session, but let me go through. So I don't know whether you guys have used Jupyter Notebook for performing any data science or machine learning analysis or predictions. So it's a very handy tool to perform these kind of operations. It's not based on a .NET it's not like a console application. It gives you run the set of commands, it gives you the output that point of time, and it stores the information about your variables. So suppose you initialized a variable with the value of 10 and you move on to another cell, that means it will be stored there and you can utilize it. So it becomes very easy for you to use this one compared to writing a machine learning or data science application in a console application. So so Microsoft recently added this thing, and okay, so I'll take you from the beginning itself. So I have a Python notebook, not the Python, the C Sharp Jupyter notebook. Let me put it in the Chrome. There it works better compared to Edge. So yeah, So this is already present in my GitHub repo. You can go through that one and have access to this one. So this is our notebook. So this is a two-part series that I have written. Wait a sec. Yeah. So this is like a three-part series that I've already written in dev.to. You can go through that one. It contains almost all the things that I have covered today. And but now I'll be showing a quick demo on that one, a direct demo. So this is your Jupyter notebook, and as you can see, I have a kernel that is C# based. So you can have different type of kernels. For example, by default, when you install Jupyter on your system, it will come with a Python kernel only. There won't be any C# or F# or PowerShell. So now you can write your PowerShell commands and see the output directly in this. You can write your C# program, F# program, any of this. So for that you need to have a kernel installed that is available through .NET Interactive. So this is the place which has some links to how to install and how to use this thing. So this will allow you to install the C# kernel, and once it is done, you can create a new notebook and start playing around that one. So it has a combination of Markdown plus cell where you can execute the code. For example, this one is just a Markdown, and the way you work here is you press on Shift Enter, it moves to the next line, it moves to the next line, and so I've just mentioned what I'm going to perform in this tutorial. So these are the different things. Like I'll be loading a CSV, then I'll be showing the description, what is present in the CSV data, and what is the information that is present, like what are the data types, and what are how many value rows are there. So this is the metadata, then displaying a set of records, maybe like around 5 record, top record, then some random records, then how you can perform a filtering on that, how you can group those things, how you can aggregate. So these are different things available in .NET DataFrame package. So yeah, this is about loading the data set, then analyzing the data set, then data cleaning I'll be performing. It is a part of your exploratory data analysis, which wherein I'll be removing the invalid cases. Then visualization I'll be performing, like number of confirmed versus death versus recovered cases, and top 5 countries with confirmed cases, top 5 countries with dead cases, top 5 countries with recovered, then one plot for India, confirm versus death versus recovered. So you can perform lot of things, but I have just for the keep the focus on the technology, I tried to keep it as minimum as possible. But you can plot any number of charts, or you can perform any kind of a data analysis on this using this frame library called as DataFrame. Okay, so this is like how you so zoom in a little bit. So if you look at the .NET application, a normal .NET application, there we use using Microsoft ML or different kind of packages. So this is the syntax for using your packages. So that means, so I've been using for this notebook, I've been using Microsoft.ml, that is machine learning, then data analysis, then Plotly. Plotly is for your plotting the graphs. Then there is a CSV helper. I'll tell you why I'm using this one. So once you, and these are the number of execution that you see. So maybe let me clear up everything. So I don't have the existing one. Yeah. So now this is like a fresh notebook which has not been executed. And once you do shift enter, you could see that it says a message that it is installing the packages. Yeah, so it has installed all these packages in my environment. Now this is nothing but like your normal C# code where you do the using statements, what all you are going to use. This is how I defined the constant that is being used across this notebook. And the best part is like all these values will be used, can be used in any of these cells. So one cell is like a execution part. So you can define one cell. In between you can add your notes as well. So the way it does is through the markdown. So you just specify this markdown syntax, and it's pretty good in that way. Then so this is something like the data that we get and that we load in data frame, that is not in a very intuitive manner. So we need to define a format for that one. So this is nothing, just to format the rows and columns that are present in the data frame object. Otherwise, if you do it without this, it will come in a very bad manner, you can say, not a very intuitive way. And these are some utilities. So for example, if I wanted to, there was a case where I wanted to remove some of the columns from my data frame. So suppose I have 10 columns in my data frame and I am only interested in 3 and 4. So I just wrote an extension method for that one. And I just put it as a utility, data frame utility. So as soon as you execute a cell, that means this whole section will be available to use in your code next, in your upcoming code, or any of the cell where you want to use it. So this is about creating CSV and replace separator. So what happened, the data set that I had, if you see here, it has comma as well. This is a preview from the data set that we have. So there was comma. So the CSV, the way it works is it looks for the commas. So in that case, it was not able to parse this one. So what I had to do, I had to replace and this comma with underscore or some other character. So this is a temporary fix, and already a issue was there logged for this one in the .NET uh, GitHub. There's already a GitHub issue for this one. So once it is available, we should not be able to doing this thing. But just for representation, I have to do this one. Now I'm loading the data set. This is nothing but your file. So what I am doing is like, this is my remote file path, which is your GitHub link. Yeah, this is the GitHub link where you have that CSV present, and you load the CSV from directly from your GitHub. So you load that one. Okay. And you can run anyone as many times as you want these cells. There is no harm in that one. So I just ran that. So this is the converted file. So earlier the actual file name was 05272020. This is after the transformation that I did because of this comma present. So yeah, now we will perform the data analysis. So for example, finding the range in the records in data set. So it tells you that data is looks like there is some issue anyway. So looks like there is some issue with calculating the date range. Okay, no problem. So I'll go ahead. Yeah. So this is my data frame that got loaded, and the place where it got loaded is this. So this is the API to load a CSV into a data frame object. So this gives you a data frame object. Now we just wanted to have a preview of what all things are present in that. So we can see these are the different columns present, and this is some extra column that gets added by the Jupyter notebook itself. It is nothing but an index, but these are the actual columns present in the system in the CSV. So as you can see, there are a lot of columns, and some of them them are not relevant to our problem statement, wherein we wanted to see how many are confirmed, how many deaths, how many recovered or active cases are there. So we can ignore this like combined key, latitude, longitude, or admin, FIPS. These all columns we can just drop off. So before that, there are different APIs available in DataFrame. For example, you have head that allows you to see 5 records. So you specify the number here, and based on that, it gives you the number of records. It's a preview kind of thing, but it's like a top 5 only. Now sample is a little different. It can gives you a random 6 values. Whatever number you specify here, it gives you the random values, random rows for that one. Now description allows you to see, okay, what is the maximum value for each column, what is the minimum value, what is the mean, and how many records are present for each column. For example, for confirmed, uh, this is the number of records that is present. So all are like constant. So that means every number, all the cases are present in the all the rows. Then you could see that for active cases there is a negative sign. So I'll come on to that one. For minimum value, the active cases coming as negative. So I'll talk a little bit on that as well in terms of data cleaning. And info will tell you the data type. So this is the data type of this column, this is the data type of this. So each column will have a different data type, and you can easily see what is the data type for each of the column. For example, some are single, some are string. This is string, this is single, and this is single because these are numbers, and these are strings, so it comes as a string. So this is also a different way of analyzing your data. Then data cleaning. So removing unwanted columns. So I wanted to remove unwanted columns. For example, now when I run this, remove all columns except the extension method that I wrote. Now we could see that COVID-19 data frame that we had, it has only relevant columns. I am interested only in country, last update, confirmed, death, recovered, active. So my focus will be on these items only and not each and everything. Now coming to, yeah. So I was talking about this negative test cases, negative active cases. So the way it is calculated is you have the confirmed cases, you subtract deaths, and you subtract the recovered. Okay. And so just a minute. Okay. So you have these negative test negative cases here present. Now this is on the base. So it should have been a positive value rather than a negative value. So we'll deep dive into this one and we'll see what is the issue. So we could see we got the invalid active filter. So what I did here is I took the active column, and from this I just took the value, the rows which have negative value. So the way we do is using element wise less than. So this is my data frame, this is the column. So column, I'll specify which column I want to have the information of. Then from that I'll do the filtering. So filtering is done using element wise less than. So I'm specifying 0.0. So that means and that filter I'm applying here to my actual data set. So this is the filter that I am applying, and this gives me the invalid cases. So these, if you look at this, you see that there are some places where you have the negative negative cases. So for example, if we take any record index y and apply the above formula like this, so you have 10 and you have 51 and 0. So 10 minus 51, it comes as negative. So which seems to be invalid because as per our formula, it should be like positive based on this. So what we can do, we can remove all these negative values because it seems that these are some invalid records. So what we can do, again we can apply a filter. So currently earlier I did a element wise less than, now I'm doing element wise greater than or equal to 0. I'm using that one and applying to my actual data frame. And once it is done, I'll just see. So after applying that one, we no more have the negative test cases, negative active cases now. So we have removed those invalid value rows from our data set. So this is about cleaning. This is one of the examples. There could be a lot of examples present. Other example could be removing the null values. So just for the brevity and for the simplification, I just introduced this much only. Now coming to the visualization, here we are going to plot the records. So from my data frame, I'm going to get the confirmed cases, death, and recovered. I'll be doing a sum of those values, and based on that, I will plot my graph. So this is how the graph is plotted using Plotly. So this is from the Plotly library. Chart.plotly comes from that one. So here we specify what type of plot you want to do, what is the values, and what are the labels. So this is very intuitive. You can mouse over these and get the values easily, and you can export, you can do perform other activities. So this is like a legend. So yeah, so this is about that. Then you can perform different operations on your data frame. For example, group by, sum, order by descending. So what we are going to do is we are going to get the top 5 countries with confirmed cases. So data for top 5 countries is not present in the CSV file. So this is not present. Now you aggregate the data from your CSV data and represent it. So this is about aggregation. And so then it was in order to get the first data frames group by is used against the country. So we are grouping against the country. Then we are getting the confirmed cases and adding those things. And in the last, we are just ordering it by descending by the number of confirmed cases. So this is all operation being performed on a data frame itself. So you can easily get all this information, and nowhere we have created a class for this. So this is very schema less. Need not to create any class or schema for this thing. Just for displaying the information, you can easily use a data frame here. Now this is how the record looks like. You have US leading, and then Brazil, Russia, United Kingdom, Italy. So these are different values that are present for the confirmed cases. Now similarly we'll go for I'll quickly go through the deaths. It's almost very similar. This is for the deaths, top 5 countries, then recovered cases. So it's like that. Now coming to the India part. So here we specify a country. So we need to tell, okay, which one to be chosen. So for example, I'm from my data frame, I'm getting list of all countries value. Then in that I'm only interested in India. So this is the filtering criteria for me. And this is the filter that I have created. Now it has to be specified in my data frame filter parameter. So once it is done, I have the India data frame. I can easily plot this also. So this is about the Indian plot for confirmed versus death versus recovered cases. Okay, so this is the part one, which talks only about exploratory data analysis. We haven't done any, you can say, prediction here, but and this is all running locally, so it's available in GitHub as well. You can download this IPython notebook file, IPYNB file. So maybe, yeah. So this is the file name, IPYNB file. Okay. Now I'll move on to the next one, the last one, and that is your part two is about prediction. So I'll quickly go through this one. I want to spend too much of time on the basics that I already covered. So this is almost very similar to that one. This is the same thing. I'm downloading the packages. Okay, let me restart it first. Okay, so this is set from the beginning. Okay, it's very convenient compared to a console application. You just write it and press and see the output instantly, and you don't need not to close or open any other window that happens in a console application. So I will find it very convenient here. So here also like different packages we have now. I'm using a time series analysis package here from the Microsoft.ml, and these are the same thing, constants, then utility function to represent the data in a tabular format. This is about the data set. So what happened here, the actual file that was present in the GitHub from John Hopkins University, it has a, it was in this format. For example, you have state, country, latitude, longitude, and it was on the right, it was the date that is present, but we were interested only in the uh, date and its values. For example, date and the total number of confirmed cases. So the way as it is a schema-less, data frame is a schema-less, so it will load it, but the number of columns will be like a number of dates that is present. Whereas now we are going to use IDataView for prediction, which is schema bound. So we don't know how many columns are there, or it may create a number of columns based on the number of dates available. So what we need a better representation is to have two columns, one with the date and total confirmed cases. So what I did is I just transformed it, and I have mentioned how I did the transformation from this set of data to this kind of data set. You can go through that one. Then as it is a schema bound, so we need to create some classes here. For example, this represents your input data set, like input CSV. So you have a date and you have total confirmed. So this has to be mapped with your input model input data set. So this is representing nothing but that one, and load columns, this index represent the column index in your CSV. So this is like 0 means it's a date, it's mapped to this date, and total confirmed is mapped to 1. So once it is done, so this is for the output. You wanted to forecast like 7, you wanted to make a prediction for 7 days. So this will hold the list of those 7 values. Then this is a lower bound and low upper bound, which is nothing but you predicted something and there should be some lower value and the upper value. So it will give you a boundaries of where the your forecast is lying. So this will be applicable for that one, but this whole class is specifically for output, and this is for input. So, and this is for visual representation only. This has nothing to do with the model. So the way it has to be represented, I just created a class out of that one. It will be mapped to that one, which will contain your date and what was the actual confirmed and what was the predicted one in that one. What are the low estimate and upper estimate. So it will hold all the information for a particular date. Now this is nothing but like a data analysis. So this is on a different CSV. So I'll use the data frame directly here. I'll see, okay, this is how it is. Then this is for tail is for last 10 values, then description, how many values are there. Okay, then this is about number of confirmed cases over time. Now I wanted to see how many cases are there in terms of the time. So date time column I'm using, and the same way it's very similar to that one only. So yeah, so this is how the plot comes. So you can see it's very similar to what I have shown in this PPT. So you can see that it has been increasing since March 22 or 21. Exponentially it has grown. And so this is just a brief about the analysis. Like it was from the duration this 2 days. Our number of records is 107. Case on first day, then case on last day, okay, like that. Now this is the main part of your ML.NET, where the ML.NET comes into picture. So this is ML context. So ML context is similar to you have a DB context, that is specific to your ML machine learning. In terms of machine learning, it is provided by the ML.NET framework. And this is where we are loading our CSV. So we provide the CSV file and we specify whether it has a header or not. So in our case, it is having a header and how it is being separated, the records. So it's separated through comma. And this is our schema or the class which will be mapped to the record, which will be mapped to the records present or the columns present in the data set. So this is very important. Now it makes it a very schema. It is with the schema only. It's not schema agnostic like DataFrame was there. So in a general machine learning problem, we split the data set. So what we are doing, we are getting the column like total confirmed. So once I load this, I'm splitting the data set. So general trend is to split the data set into of 70-30, but here I have used like 92 or 93 because we are just predicting for 7 days. So that works quite well for me. So I'm just splitting the data set accordingly, and it gives me like this training data set range, then test data. So training I'll be using for train data set, I'll be using for training model, whereas test I'll be using for validating during my evaluation. So this is done. Now ML pipeline. So this is how ML pipeline. This is the main thing. Yeah. So this is your ML pipeline. So here you have this is the formula for API to use for ML pipeline from ML.NET. You specify the output. You specify the input column name. Then window size is how you want to move ahead, make the predictions. So you want to take 7 days of predict past values, or you want to take 1 week, 1 month, or like that. So I have provided only 7 days. Series length is like I had a training sample of 100 rows. So I'm using that one. Out of 100, I wanted to split my data set into 30 chunks so that it can be utilized as a chunk by chunk. It need not to go with all the things. Then forecast prediction, it's like for how many days I wanted to perform the prediction. So in my case, I'm using 7 days. I wanted to predict for next 7 days. So this is about that one. Horizon is nothing but your prediction, forecast prediction. Then training size is 100. Then confidence level is about it could be around 90 to 95, like how you want your predictions to be very close to the actual one. The upper bound and lower bound, it is specified, it's always depend on these two, this parameter confidence level. So suppose I'm providing a 95, that means the lower bound and upper bound should vary between 5% of that one. Now this is the pipeline. Now I'm going to actually train the model. Okay, I've trained it. I have, now this is the evaluation. So this is the place I'm getting the predictions. Now this is once I uh, do the transformation, I'll get the predictions and I'll see what is the actual and what is the forecasted values. So there are different metrics available for evaluating a model. Currently, I have used mean absolute error and root mean squared error. So mean absolute error is about how close our predictions are to the actual value, whereas RMSE summarizes the error in the model. So this is quite high, but the value near to zero is good enough. We need to target that one because currently the uh, data set that we have been using, it's not very big. It's for like 3-4 months only. So that's why the prediction is not very great. But we should not be aligned only with these values. We should see other things as well. Now, once you have evaluated your model and you are convinced, okay, you are good to go with the model, then you can just save the model. So what it does, it saves the model into the path as a model.zip file. So it saves it as a zip file. So that zip file can be used for your deployment within your Azure function, within your Azure console app, within your web API, any place. So it will generate a model.zip in the folder where you have this notebook file present, or the path where you specify. Now this is the main thing where we are going to make a prediction. So what we are going to do, we are saying, okay, we have to make a prediction for 7 days, as we provided the value for horizon as 7, so it will make a prediction. And this is the value, so actual confirmed, then the forecasted value. So 33 is the actual for this date, then these are the different dates, and these are the values for that, and these are the like lower bound and upper bound for that one. Now if you want to visualize this thing, it comes up like this. Yeah, so till here we had the actual data, and these are the predicted one, and there is a slight gap here. The reason being it may be because of the less number of records in the data set, plus we need to tweak a little bit on this one. So I just kept it very nominal, just to make sure that there is a scope of improvement in this model, and we can tweak different parameters that is present in the for the model, and we can improve the accuracy based on that one. And this is for lower bound and upper one. So middle one is the lower forecasted value, and these are the lower and upper one. So generally it's preferred that the gap should be minimum between all these values. So we need to improve this on this as well. And here it is only for 7 days, we can see here also, like we get 7 days, but the good part is like we can see a trend that is matching with the past values. So that says, okay, the according to the trend, the things will not improve. It will be as similar to what we have in the past 7 days. So this is a brief analysis about that. Okay, that's all. I think I'm almost 8 minutes ahead of the past the time that was allocated. So I'm done from my side. Just feel free to ask any question you have at this point of time. And thank you very much for joining this session today.
Thank you so much, Praveen. I
Hi.
uh, Great session. I guess everyone been asking questions, lot of questions.
Okay.
So, perfect. Then I'll be sharing the recording